and we can figure out what will be the natural scale. This will be the natural scale. All right. So now if the natural scale is given to you, you can derive your longitudinal scale from that. All right. So, but you have to understand one thing. This natural scale is at the equator. If I have assumed 1 minute of longitude here as 1 centimeter, this is valid over here. So this natural scale is for this equator. So if I have to convert it to the natural scale at this latitude, I must find the departure at this latitude between that much of longitude. I must find that departure. All right. So the question says that natural scale is 1 is to 10,100,000 in latitude 43 degrees north. Okay. So that means at 43 degrees north, 1 centimeter on chart is equal to 10,100,000 centimeters on the earth. Okay. But at latitude 43 degrees north, 10,100,000 centimeters is the departure. Okay. Suppose if I take the distance between longitudes, so that will be the departure, and that is what the distance scale is. So I must find out what is my longitude scale over there. So first of all, let's see at equator what is the at equator 1 degree of longitude is how much? 1 degree is 60 minutes. 1 minute is 1852 meters, and if I want to find out in number of centimeters, then I'll multiply by 100. Okay, and it will come down to 20,000. Okay, 20,000 centimeters. Okay, so this is the natural thing. 1 degree of longitude measures this many centimeters on the earth in actuality, but we need that 10,000 centimeters in 43 knot should measure 1 centimeter on the chart. All right, so what will be the departure at 43 degrees north? The departure will be the d long into cos of that latitude, as we have seen earlier. So the d long is this much centimeters, right? So 1111 20,000 into cos of 43 degrees. Okay, so we get the departure at 43 degrees north, and how much that will come out to be? Around 8126802. 8126802 centimeters. So the distance between the meridians at the equator was this many centimeters. The distance between the meridians at 43 degrees north is this many centimeters, which is the departure. So now this is the east-west distance. Right? And our scale says, which the scale which is given is that 1 centimeter should be equal to 10,100,000 centimeters on the earth. So if 10,000 centimeters measures 1 centimeter on chart, then how much will 8126802 centimeters should measure on the chart? So you divide it by 10,000, 10,000,000. So 8126802 upon 10,000,000. So you'll get 8.12 centimeters. What it means is the distance between 1 degree on my chart at 43 degrees north should measure 8.12 centimeters. Okay, so we have arrived at the distance between two meridians 1 degrees apart at 43 degrees north according to the natural scale that was given to us. Okay, so we can start off the chart. We can start now with the chart by placing the meridians at that much distance apart. So, okay. So, I'll draw a line and my first meridian is 60 to 64. So, okay, 60. Then at after 8 centimeters, I draw another meridian 61 degrees, another 8 centimeters, 62 degrees, 8 centimeter, like that after 64 degrees. All right. So I got my meridians in place on the chart. Now I need to find out what is my latitude scale, because okay, you can divide this 8 centimeters into 60 parts. Okay, you'll get each minute. But the latitude scale is different because at 43 degrees north, the latitude will have a north-south expansion. All right. So for finding the latitude scale, we can use that formula also. Latitude scale is equal to longitude scale into secant of latitude. But that formula is valid for each minute. So you'll have to calculate for each minute or very close by, and you'll need many calculations. So by drawing a chart, it's better that we use the meridional parts. So what we will do is, suppose we have to construct from 41 to 45. So this is 41 degrees north, this is 42 north, then you will have 43 north, all right, like that. So we will find out the meridional parts for each of these latitudes. So from the tables, the meridional parts are given in your Nouri's or Travers tables. So you just note down what are the meridional parts for each latitude. So I'll just take one example. For 41 degrees latitude, meridional parts is 2686.24. 2686.24. And for 42 it is 2766.05. 43 2847.13. All right. So between 41 and 42, you've got meridional parts, so you can find out the DMP. DMP between 41 degrees and 42 degrees. Okay. So just subtract 2766 to its how much you get is 79.81. Okay. So this is DMP is 79.81 between 41 and 42 north. So we know what is DMP. DMP is the number of minutes of longitude that can be put in this between 41 and 42. Alright. So if I have a longitude scale which says that 1 degree is 8.12 centimeters on the chart. Right. So what should be our latitude scale? Okay. How many minutes or how many degrees of this latitude will come over here? Okay. So the distance between 41 degrees and 42 degrees. Okay, so we have to find out the distance between 41 and 42 north. So the DMP is how many minutes of longitude can be placed in this between these two latitudes. So according to our calculation, 1 degrees is 8.1 degrees of D long is 8.12 centimeters. So 1 minute of longitude will be how much? It will be 8.12 upon 60 divided into 60 parts. Okay, so if 1 minute of longitude is this much and your DMP is 79.81, all right, so this means you have to multiply the DMP 79.81 into the length of each minute of longitude. So length of each minute of longitude is 8.12 divided by 60. Okay, so that will give you around 10.8 centimeters, right? 10.8 centimeters. So by our natural scale, we have come down to the longitude scale at 43 degrees north. So longitude scale was 1 degrees D long is 8.12 centimeters. And from that longitude scale, using the DMP between 41 and 42, we came down to how much is the distance between 41 and 42 on the chart. So this is 8 centimeters and this one will be 10.8 centimeters. Now again you have to do the same exercise DMP between 42 and 43 and the distance between 42 and 43 by multiplying the DMP by the length of 1 minute of longitude. Okay, so you multiply the DMP between these two latitudes by the length of 1 minute of longitude and you will get the length of this portion. So each portion, the length will be different. It will increase as you go up. This is 10.8. This might come as 11.2. This might come at 12, like that. So to keep that north-south distortion on your chart and to keep that orthomorphic property, you must calculate the length between two latitudes for each degree of latitude. And once you calculate for each degree, then you can just keep on marking your latitudes at those distances and you come down to your Mercator charts. Okay, so that is how you go about construction of Mercator charts. Okay, thank you, gentlemen.